Hello, future AP chemistry students. This is Mr. Spurk, and we're just going to do a quick review of solids, liquids, and gases, just to talk about their particles, their motions, and so forth. So we're going to first start talking about solids. So with solids, the general properties of solids are due to their orderly arrangement and their fixed positions of their particles. Remember that solids are tightly packed together. Solids are dense. They are not easy to compress. They do not flow, and their particles vibrate at their fixed points. So they're not sliding around, they're just vibrating in place. When you heat a solid, the particles vibrate more rapidly as their kinetic energy increases, and that is what we call the melting point. This is the temperature at which a solid changes into a liquid. The freezing point is the temperature at which a liquid changes into a solid. Those temperatures are the same. All right, ionic solids have really high melting points because of the relatively strong forces that hold them together. Remember, they have the ion dipole force, which is between the electrostatic charges. And then molecular solids have relatively low melting points because they have things like London dispersion forces. Maybe some of them have dipole-dipole forces. So they have those weaker intermolecular forces, which causes them to have lower melting points. All right, so that's it for solids. Let's go ahead and talk about liquids real quick. So as far as liquids go, substances that can flow are referred to as fluids. Both liquids and gases can flow, so gases and liquids are both considered fluids. This allows them to conform to the shape of their container, and that's their big difference between solids. Gases and liquids, although they can both flow and are considered to be fluids, they have a key difference between them. According to the kinetic theory, there are no attractions between the particles of a gas, which means they spread out to fill their whole container. They don't want to be near each other. The particles in a liquid are attracted to each other. Their intermolecular attractions keep the particles in a liquid close together, which is why liquids have a definite volume. So liquids have a little bit stronger intermolecular forces, and that's what holds them in the liquid state. Remember that their particles can slide or translate around one another. They do more than just vibrate, that they flow, but they are not spacing out like gases are. The interplay between the disruptive motions of particles in a liquid and the attractions among the particles determines their physical properties. So liquids are much more dense than gases are, and we can increase the pressure on a liquid, and it doesn't have a big effect on its volume. The same is also true for solids, where we know that if we change the pressure or volume of a gas, it's going to affect the other. Let's jump over to gases now. So as far as gases go, we're going to talk about the kinetic molecular theory. The kinetic theory says that all matter consists of tiny particles that are in constant motion. The particles of a gas are usually molecules or atoms. And the kinetic molecular theory states a few postulates. The first is that the particles in a gas are considered to be small, hard spheres with insignificant volume. Within a gas, the particles are relatively far apart. Between the particles of a gas, there is just empty space. There are no attractive or repulsive forces that exist between the particles. It also says that the motion of particles in a gas is rapid, constant, and random, which allows for gases to collide with one another as well as the walls of the container. Gases are going to fill their whole container, and an uncontained gas will spread out without limit. The particles travel in straight line paths until they collide with another particle. Those collisions are elastic, meaning that the kinetic energy is transferred from one to another. And that's where we'll end it.